We've already seen a little bit about projection of one vector onto another. Matter of fact, we've discussed that in the context of dot product. And we've talked about how you can calculate the projection of one vector on another using the dot product. That's not what we're doing here. What we're going to do here is we're simply going to learn to draw and estimate. I don't know if you have to learn to do that or not. You might already know how to do that. But we're going to draw and estimate the projections of the projection of one vector on another. Okay, so let's take the v and w vectors here. Okay, if I want to project v onto w, that means I want to drop a, and of course I've got v and w drawn with common endpoints. Okay, if the vectors don't have common endpoints, you're going to have to move one of them or both of them to the point where they have the same common endpoints without affecting the length or the direction of either vector. Okay, now to project the v vector onto the w vector, simply need to draw a projection line at a right angle to the w vector starting from the end of the v vector. And then the projection vector is just this. So this is the projection onto w of the vector v. Now over here I want to project the vector w onto v. So I want to find the projection onto v of the vector w. I can't draw a line from this end of w perpendicular to the vector v. Okay, so what am I going to do about that? Well, all I do is I extend, not extending the v vector, but I'm drawing a line that extends the direction of the v vector from the tip of the v vector on out until I get to a point where I can easily project w onto that vector. So here we go. So there is the right angle. There's the projection. I have kind of an unfortunate labeling here. Let me try to get rid of most of that. Okay. What I want to do is I want to label the projection vector, which is from here to here. And this is the projection onto v of the vector w. And this is the vector v here. I'll label it here instead of here where it was going to be in the way of this labeling. Okay, so that's a fairly simple process. There's no hidden subtlety to the process. You simply have to project one vector onto the other or onto a line extending the other. And in some cases you might have to extend the vector onto which you're projecting backwards. For example, if the w vector was down here, we'd have to have an extension along here in order to project it back. Now, one thing that I'm going to ask you to do here is I want you to copy each of these as best you can and sketch the projection. And then I'm asking you to estimate the length of the projection as a percent of the length of the projected vector. Now let's see what we mean by that. Well, here's the projection of v on w. Hang on a second, I'm looking for something to use. Okay, here's the projection of this vector onto w. Now, we know that if we draw this thing, the projection line at a right angle, then this vector forms the hypotenuse of a triangle of which this vector is an adjacent side, so that this vector has to be shorter than this vector. Now let's see if I really did that. Of course, there's some imprecision in what I did here. Okay, there's an indication of the length of the v vector. If I bring it up here, it comes to about here. It looks like this vector is at least 90% of the length of this vector. Now, I'm not sure I did the projection all that well. It actually looks like maybe my right angle is a little bit acute. And it's, yeah, I'm not making any strong attempt to make this really accurate. I could take a piece of paper and test that angle, and we see that, yeah, okay, I screwed up the projection line a little bit. It comes out from the perpendicular somewhat. Let's see how I did over here. See if I can stay out of the way. I think I did somewhat better here, but no, the projection line comes out this way, so that this angle is actually a little bit obtuse. Okay? So I haven't done a real good job of drawing accurate projections. I do want you to have some uncertainty in the estimates you're going to make, and I want you to do this by eyeballing the projection lines, because I want you to learn to see what you're calculating. Now, if I measure the length of this purported projection vector, okay, I'm going to come out to this corner of and I see that it's almost as long as the W vector, at least 90% again. Okay? So maybe if I improved the right angles, I'd get more accurate estimates. I think the over 90% might be a little high for both of these projections. Okay, in any case, using the same techniques, I want you to just copy these three. I want you to estimate, well, I want you to first draw the projection one vector on the other and estimate the projection as a percent of the original vector. The length of the projection is a percent of the length of the other, and then project this second vector onto the first. Okay, so we project for this given picture, we project this vector onto this one, then we project this vector onto this one. So that's going to be 8 projections you do for the 3 vectors. Also, if your vector, if your vector is negative, you're going to want to report a negative percent. So I want you to do that, and want you to just submit a form, or submit a form, just a submit work form with those results, okay, in order for the 2 projections on the first, second, third, and fourth sets of vectors.